Ranger 2, prepare to detach.
What? No! No! Cooper!
3.
Cooper, what are you doing?
Newton's third law. You gotta leave something behind.
Hello, Mustafa. So this is AQA AS Paper 2 2020, question 3. So you put here, for this question, why can't I resolve vertically? Okay, so let's have a look at the question then. So figure 6 shows a camera filming a sports event from above, a bit like those spider cams. Position of the camera is controlled by two steel cables, a pit, passo, or a fixed smooth pulley. So there's no friction there. In figure 6, the camera is stationary, so the resultant force is 0. So forces up equal forces down, forces to the left equal forces to the right. Tension in A is 430, so that's 430 newtons. Makes an angle 35. So what do we know? That's got, so this is the vertical component, which is the sine. Okay, so that's 430 sine 35. Probably don't need this, but let's have a look at it. And then this one is 430 cos 35. That means we've got a tension in here. Let's call that TB. Okay, so this that's TB sine, sorry, cos sine 12, and then this one over here, that's TB cos 12. So let's have a look at what the question asks. Calculate the tension in B. Right, so you says, why can't I resolve it vertically? In order to resolve it vertically, you need to know the weight. Okay, so why not just resolve horizontally? Because you know TB cos. So what do we know? We know TB cos 12 must be equal to 430 cos 35. So we can work out tension in B. It's 430 cos 35 over cos 12. So let's put that in the calculator. So that gives me 360 meters. Hopefully you'll see why your question doesn't make sense anymore. Okay, all the learning curve must have. So let's move on to the next one. So the camera is moved horizontally to the right to a new stationary position. Tension in A is now different from that in figure 6. Deduce whether tension in A has increased or decreased. So it looks like you missed that 3.2. Maybe that's just another part of the calculation. I'm thinking if you've got the tension, they'll probably ask you something about Young modulus maybe. Well, let's have a look at 3.3. So that's the one you're stuck on. Now, the camera is moved to the right. So if you, first of all, let's take the obvious stuff. So I'll do it in blue. If you move it to the right, that means it's gone that way. Now, let's just draw it in a new position. So here's the camera. What do you notice? So what do you notice about there's TB and that is your TA? Well, hopefully the first thing you notice is the angles have changed, haven't they? So take the obvious first, then let's talk about the consequence of that. So theta A decreases and theta B increases. I hope that's obvious. Now, if you look in the original, tension of A was bigger than tension of B. Why is that? If you look at it, more of the weight is supported by A because it's closer to A. Okay, so if you look what's now happening, more of the weight, which is the energy that you couldn't use earlier, is supported by TB because it's closer to it. Pulley on the okay, so there's your mark step. Okay, so you could have to the right. Alright, so you could have anything else you could have talked about? Possibly you could have mentioned the ratio. You could have gone back to this TB, this bit here, talked about that in there also. Okay, so how these numbers are changing. Okay.